It's my pleasure to introduce Professor Assaf Zeevi. He is the Kravis Professor of Business at Columbia Business School and is the co-faculty director in Columbia Executive Education's new program, Artificial Intelligence for Business Transformation, coming this fall. His research focuses on operations research, statistics, and machine learning. He is the recipient of several teaching and research awards, including Career Award from the National Science Foundation, the IBM Faculty Award, Google Research Award, as well as several Best Paper Awards. He serves on various other editorial boards and program committees in the operations research and machine learning communities, as well as scientific advisory boards for startup companies in the high technology sector. Assaf, it's great to be with you again today.
Likewise, Scott, great to see you too.
Great, so I'm going to leave the stage and I will rejoin you in the last 10 minutes for the Q&A.
Thank you very much. All right, welcome everyone. Great to have everybody here. I'm gonna launch directly into the slides. As you probably know, there's gonna be a recording available after the webinar. Q&A we'll take at the end, but do submit your questions, etc., through the appropriate Zoom link, and we'll vet them and address them in the last 10 minutes of the webinar. So let me jump directly into the thick of things. The purpose of this webinar is short, it's 20 minutes, so we're going to give like a really broad overview of a few of the ideas underlying machine learning AI and give some illustrative examples of how these technologies are really changing the way that certain functions are run today. To understand AI, the first thing is to understand it's not a single technology, it's a collection of technologies that we're referring to here. And each technology is in fact evolving pretty rapidly. So it makes it a bit hard to define. Usually we sort of resort, for lack of anything better, we resort to a mission statement of the form that I have on this slide, which says that we're looking to essentially synergize technologies and enable machines to sense, act, and learn in a manner that resembles human intelligence. So it's more of an aspirational statement than anything else, but that's usually what we refer to. One of the points of confusion in AI is the distinction between AI and automation. So automation has been around since Industrial Revolution. AI is not automation. It's more about deciding how to act based on analyzing data, and it's not about hard coding. So automation, a lot of automation is just basically process, just turning a set of operations into a process which is automated. An example that we'll touch upon in a second is chess playing programs that used to hard code everything, and now they've shifted into a much more experiential learning type of model that has produced quite impressive results. So for example, recent such programs can compete with the top players in the field by learning to play pretty much on their own with very little guidance or hard coding done through a set of technologies referred to as reinforcement learning. So more on that in a second. Again, chess playing programs have sort of served as a interesting lens for us to look at the evolution of AI, just like video games. In many ways, these technologies like video games have been pushing the frontier in many areas, including computation. So this popular Netflix series is, I think, brought a lot of general interest in chess for those who may not be that interested. And what we're seeing essentially in chess is the following type of evolution. I'll discuss a bit what we're actually seeing here. So, oops. So the first chess playing program, which is the one that you're seeing here in this snapshot, was an extremely rudimentary computer, and we're dating back to 1977, with essentially, you know, the capacity, memory capacity, which is almost you can think about it as minuscule relative to what you're walking around today in your phone. So you couldn't store a decent picture in this memory bank this computer had. And what you can see, the way it sort of functions is that there's this rudimentary computer that basically spits out the moves, and then you execute them on this chessboard. There's a fairly elaborate manual that goes along with that. This was the launch of this whole area of designing programs that can actually play. If you jump forward about 20 years, this is probably the first main foray of high-powered computing into the space, with a program called Deep Blue that was innovated by IBM Labs. It was dedicated to playing chess. It used a lot of computational tricks to become effective, and it was tuned. An important element that I want to emphasize here is that it was tuned with the aid of chess masters that helped it essentially learn what's important and not important, like gambits and so on, how to assess various board positions. At the time, again, circa 1997, it was considered one of the top supercomputers in the world. So this is not, some minor chump piece of computing equipment. And in fact, in recorded history, this is the first time that we have a chess playing program, Deep Blue, that won in a tournament type condition, playing against a reigning world champion, Garry Kasparov. So it was an important landmark in the evolution of AI. You see a snapshot of this in the picture here. And if we jump forward about another 20 years, so we're working on 20-year increments, a program called AlphaZero, which is an innovation coming out of DeepMind Labs. This is a company that was situated in Great Britain, was acquired by Google a few years ago. They built a multi-purpose AI program, not dedicated to chess in fact. And here, essentially, all the handcrafted rules and the tutelage of the grandmasters was replaced with what's known as deep neural nets and very general purpose algorithms. So this program can actually be used to play a variety of other games like Go, checkers, backgammon, and so on. What you do is you take this so-called neural network, and essentially, like a baby learns, you show it a lot of possible games, and you allow it to experience in the game, make mistakes, etc., and learn from those mistakes to improve its strategy through a process that I referred to earlier as reinforcement learning. And this was a fairly significant innovation in the sense that there was no hard coding done here. To understand a little bit about how the technology actually works, and again, we don't have time for this here, obviously, but in the course that we're launching, we will definitely dedicate a little bit of time to understanding some of the core concepts so that we're not diving into technical details at all. So at a high level, what's exactly a neural network? So you see a picture here on around where my cursor is on the left side. This is a simple neural network as opposed to what's known as a deep neural network, which is on the right. And what happens, this is, the name comes from the actual way that neurons work in the brain. There's a layer, this blue layer, which is the input layer. You can think about that as where you acquire something from the outside world, like vision. You get a signal from the outside world. Then the yellow layer is where, between the yellow and the green is where most of the processing takes place. This is where all the connectivity of the neurons comes into play, and where we take the image and do some processing on it. We extract edges, we compare it to different templates that we have in our memory, and so on. And then the output layer, the green layer, is where you actually come out with something like an identification of an object, a move on the chessboard, etc. So this move from this simple neural network that was very hyped up in the 70s, 80s, to this deep learning model has been one of the things that characterizes the recent advent of AI technologies in general. Now, when you think about AI, companies that claim to be AI companies or that use AIs sit somewhere on the spectrum between using very basic statistical tools all the way up to fairly advanced AI tools like DeepMind, for example. And in some ways, a lot of the ideas really originate with statistics, models to capture data, core techniques like regression and other things that we'll also touch upon in the full course. And there's a lot of similar philosophical ideas. But it's also very different in the sense that a lot of the models that we use in AI, like the deep learning models, they're very complex, very hard to understand, just like we don't really understand exactly how our brain processes various information, but we know what the output is. This is referred to as a black box type approach. We don't really know what's inside the box, but we know that it's doing whatever it should be doing in some somewhat magical way. It's much more algorithmic than statistics. It's about turning things into computation, converting ideas and models into computation. And therefore, again, it's about integration of how to represent things, how to optimize, and how to compute, which is, again, very different historically than what statistics focuses on. I mentioned earlier the mission statement of AI, which is a way sort of to indirectly define it. We think about this as a way to sense the world, acquire data, comprehend, which is building a mental picture of what's around us, and then converting that into a layer which makes decisions, just like chessboard, how to make the next move. And then ultimately, critical to this last evolutionary step in the chess playing programs, how do you take the result of your action and convert it into some learning experience, a signal? This is the term that I used previously, reinforcement learning. I see what's happening. I see that my pawn was removed from the board by an attack by my opponent. Hopefully next time I'll understand that that move wasn't very successful, at least in the short run. So things of that sort, which is essentially the experiential learning part of AI. Just to give you a really high level sense of one of the core ideas that distinguishes AI technologies, we often differentiate between supervised and unsupervised learning. You can think about this as learning with a teacher and learning without a teacher. Just like those chess playing programs, there was a grandmaster that was providing the classification of what are apples, or labeling the apples, like labeling good moves. And then the model sees a lot of these apples that are labeled as an apple and knows that they're apples. Whereas if it's an unsupervised learning technology, which is now becoming much more prevalent in AI applications, what you feed the model is essentially all this input data, all these fruit, but there's no experts to tell you which is what. And then the model somehow is to classify this into the buckets, which are the bananas, the apricots, and the apples. And that's something which is done endogenously in the model without the aid of any hand-holding. This slide, again, is just a very high-level view of what machine learning AI technologies bifurcate into. You can see here, again, this core pillars of supervised and unsupervised learning and the emerging area of reinforcement learning that you're seeing below, and its various applications, like to anything from robot navigation, video games, skill acquisition, etc. So this is just to give you like a really high-level picture of how the field bifurcates into high-level hierarchy of ideas into lower-level, more granular ideas. And again, in the course that we're going to be giving in the fall, we'll dive into some of these without a lot of technical details, but we'll dive into some of these concepts and their applications. Now, AI has had in the past a lot of peaks and lulls in terms of attention, hype, etc. But I think this time, this round is for real. It's here to stay. And one of the reasons for that is that all the stars are lined up now. That first chess playing program, one of the bottlenecks was, Boris, one of the bottlenecks was we just didn't have the compute power, the ability to basically create something that wouldn't fill a whole building that could actually execute the moves, whereas now we can do it on our phone. So we have cheap, pervasive computing. We have a lot of data available, the so-called big data revolution, and the digitization and access to the data. We have a lot of cheap and accessible hardware for storing, et cetera, which is also very important for AI purposes. And we have a lot of success stories across the globe of major tech companies which are worth, billions of dollars, all the way to a plethora of startups that are working in this space and innovating as well. So everything is ready and ripe for this to basically stick around for the foreseeable future. I thought that in the remaining time that we have, we'll just skim through a few little examples of how AI is used. So medical imaging. Imaging in general is one of the first big success stories of AI. You can see here, for example, how AI can be used for diagnostic purposes, where the original image let's say if it's, up until a few years ago, you take an X-ray, you'd actually read the film as opposed to a digital version of it. Now it's acquired by the visual sensors, immediately processed by AI technologies to provide this image on the right, which is much more crisp and clear. Like if you're diagnosing, soft structure in that joint, you can easily see all sorts of deformations or degenerative disease, et cetera, in a much clearer way. So this is facilitating the work of the radiologist in a very significant way. I mentioned video games. You can see here, this is true for both the ability to play multiplayer games, and certainly when we're getting into the world now of adding augmented reality, virtual reality, you can see the difference between the two images. This is all done, again, by AI technologies. Even this poster on the wall here that you're seeing, barely understandable and decipherable in this upper vision, you can see after this super resolution enhancement how clear that poster is. And a lot of this is done by recognizing what's underlying that distorted initial view, and this is using these deep learning technologies. Again, visual acquisition and interpretation, very critical for a lot of applications. Here's an example of facial recognition, classical challenge that's been around for years. Various world leaders, and you can see they're marked, everybody except Merkel, and I guess also and Macron. I think both of them are not marked here. So it's a result of the directions that you see in the image and the ability of the computer to actually analyze and understand this correctly. You can imagine this has a lot of applications also for various surveillance programs, et cetera, but this is a completely civilian application here. And the problem with these, the challenge here is that you have to work under very adverse conditions. For example, here you can see an actual deployed technology that works in hospital environments and recognizes this position, despite the fact that you're essentially only seeing a small strip of characteristic visual features around the eyes. Everything else is distorted. And in this left image, you can see a case where you're identifying a set of people that we can't even see here because it's so dark, but the technology is able to actually recognize them by means of using a variety of visual acquisition and the AI layer that does the recognition. These are actually deployed technologies already. Everything that I'm covering here are deployed technologies, various companies that I've also been interacting with heavily over the past few years. You've probably all heard about the autonomous vehicle space. All the major companies are investing heavily in that, both in terms of the actual mechanics and the brain, how to actually run the car in an autonomous mode. And you can see here an illustration of an actual platform that recognizes the cars in green in this intersection, recognizes the lights, and recognizes pedestrians and cyclists and separates them. This is a bit of this unsupervised learning technology that we touched upon earlier with the apples, bananas, et cetera. But this has to happen in a very dynamic and rapidly changing environment. And again, just like the previous pictures, you can see that this has to happen under adverse conditions: rain, snow, poor lighting. You can't just pick and choose where this technology is going to work. Otherwise, it's not going to be deployed with any reasonable level of reliability and confidence. Again, the recognition of the pedestrians on the sidewalk, the cars in the street, et cetera. All of this is an actual technology that's already deployed and running. The last example that I thought I'd give you is also something a little bit less familiar maybe than autonomous vehicles, et cetera, that you probably have heard about quite a bit. This is a snapshot from an actual corona ward in a hospital in Israel. And you can see here on the computer screen, there's something which is like a command and control panel that I'll talk more about in a second. This is a technology that's been deployed under an emergency use agreement in these corona wards to help monitor the COVID-19 patients, especially to avoid rapid deterioration or to alert on rapid deterioration. And one of the reasons to deploy this under fairly unusual conditions is because the staff was stretched so thin. So this is a blow up of what you saw on that computer screen. This is essentially giving you a high level command and control of the patients and in the department. You can see those in red are those that are at high risk. The yellow are stable, but not yet out of the woods. And then the greens are in stable and require less attention. This gives a tremendous amount of versatility in allocating staff resources, prioritization, et cetera. Again, it's a system that's actually implemented, deployed, running in at least 3 hospitals and clinically trialed already in the US as well. This is just a slightly more granular view of what the doctor actually sees. If he double clicks on one of those patients and wants to see more, for example, why is this patient in red and not in yellow? You can see here, for example, various vitals and so on that characterize respiratory distress. And it signals essentially what are the things that are going on in the patient's physiology that have led to this classification. One of the reasons I'm mentioning this and the previous example on autonomous vehicles is that the AI is also required to be interpretable. Otherwise, the respective industries will have a hard time adopting it. So here too, it wasn't enough just to create a system that raises red flags. You needed to say something about why you're raising a red flag, what's going on, and that requires a good intimate understanding of physiology and acute care in order to create a custom system that can be successful. And I'll sort of close with that, like a parting word before we finish this part and move to the live part, that one of the main challenges also in AI technology, despite the tremendous promise that you see also in these applications, is it's very resource heavy if you're customizing it to an application. You can't just, we're not at the stage where you can just grab an AI technology off the shelf, plug and play. There's a lot of custom development in all these applications I mentioned. There's a tremendous amount of custom development. That's where usually the secret sauce resides. And that requires both institutional knowledge and good knowledge of AI. Those are some of the things we're trying to capture in the course that we're launching in the fall. I want to invite Scott to step back in because we're done with the monologue part and we can start, addressing maybe some questions, et cetera, to see what people are interested in hearing more about.
Great, thank you, Assaf. It's such great, interesting information. Very excited about the upcoming program. I just want to begin this with saying that one of the things we've talked about is that this program is not a program, it's a program for leaders to understand AI technology more than for AI experts, right? So that's sort of the focus of understanding the benefits of AI within organizations. And so
absolutely, I think the program, exactly as you said, that's we've tailored the program to people who are not AI engineers or data scientists. These are people who are actually decision makers who need to have a broad understanding of what's possible, what's out there, what's possible, how have various organizations used these ideas to really change the way that they do things, how have they become leaders in this field, how has a company like NVIDIA moved from being a niche company in the video game space to and computer graphics card space into one of the world leaders in AI. That's not a very natural transformation. Or how does an online supermarket become a leader in AI? So these are the things that we're going to try to touch upon in that program.
All right. Well, you're in your summary at the end, you sort of touched on this question, but I think it's a great question to begin with here from Byron, just sort of a general overview. He asks, how do you assess where we are on the promise of AI on a scale of 1 to 10? And you mentioned, he's asking about its primary limitations, which you mentioned a little bit in your summary, but what are some breakthroughs that are going to be needed to realize true wider application?
It's a great question, and I think indeed it's actually one that the jury's still out. I mean, we don't know exactly where to place ourselves on that evolutionary scale. There have been, as I mentioned earlier, in many ways the stars are aligned. Like all the raw materials are basically there. I think what we're missing a little bit is the ability to provide these custom solutions in a cost-effective way. And I saw that there were some questions also in the chat box about that. One of the prohibitive factors, if you want to go in and build a solution like I indicated for COVID-19 patients, well, that's about 3 years worth of work. So if you start doing it when the pandemic started, you're never going to be able to deploy anything. This is a company that we've been developing this technology for about 3 years, and then the pandemic hit. So we basically just aligned it a bit to fit the COVID patients as opposed to just general ICU, general purpose. And that's one of the big obstacles here is, again, developing such a technology requires a lot of expertise, knowledge, domain knowledge expertise, and AI expertise. And putting that all together is something which is still very far from being like a cookie cutter type of solution.
Great. Well, so next up, I'm going to combine a couple of questions that came in, one from Amelia, one from Alberto. He says, what industries are you seeing AI use the most? And can you, even in that, who are having the most success at leading the way with AI?
Yeah, I assume I'm not going to be shattering anybody's sense of reality by saying this, but the big tech companies are definitely on the frontier here. They've embraced the technology very early on. I mean, Google, for example, did not start off as an AI-oriented company at all. Web search has elements that combine some computation, some statistics, but I wouldn't really classify it as AI. And over the years, they've morphed into one of the main AI centers. The same with Amazon that I was alluding to earlier as a supermarket, right? You start off selling books, and now you're basically designing ways for smart automation, smart homes, and a variety of other applications that are all AI focused. In fact, a big chunk of R&D in Amazon is AI. Same with Facebook. You start off with building a social network, a medium for communication among people that have share some connection. And today their labs are creating virtual reality devices. So I think big tech companies for sure are on the innovative frontier. Security applications, if you look at military intelligence, security, NSA, for example, definitely on the efficient frontier in terms of implementing AI technologies. And if you look around in startups today, you see that there are really interesting areas that are somewhat non-traditional. For example, there is an enormous amount of innovation and disruption that's going to take place in agriculture over the coming years. We haven't heard much about that, but it's in the labs or in the garages. But I think that within 5 years, we're going to see some really innovative solutions that will change the way that we approach that entire area. So, there's a more traditional Facebooks, Amazons, et cetera, and a lot of stuff that's happening right now, which is extremely exotic applications of AI that we haven't heard about.
Right. This is an interesting question just came in from Balaji. As regulations take hold of data access and privacy becomes a priority, will this change the direction of AI?
Yeah, so AI, one of the challenges of AI is actually to deal with things that you probably heard about, like privacy considerations, like that healthcare application FDA regulates. Now, it turns out, and this is from personal experience with the FDA now, having now received the emergency use authorization from the FDA, they don't really have a way to assess AI. They don't have the internal capabilities. This is not an organization that's extremely innovative. And I don't think they foresaw the amount of development that's going to take place in AI. And now they're faced with all these challenges. How do you authorize an AI technology? How do you deal with all these considerations like patient privacy, anonymity, and so on? It's creating a lot of obstacles that, again, the regulators will have to step in and be much more active and proactive. The autonomous vehicle space, if you think about a really basic question like, God forbid there's an accident, we know today who's responsible. One of the two drivers or both, and the insurance companies can sort it out. But if an autonomous vehicle runs into another vehicle, who's responsible? Is it you can't sue the computer chip, right? So the regulator has to step in and really do a lot of cleanup. And that's true for across the board in many areas. We're not talking just about, Cambridge Analytics. We're talking about a variety of other things which are very basic at the core application layer of these technologies.
Great. We're at 10:30, but there's so many good questions, a lot of energy. Can I ask for maybe 5 more minutes of your time?
Absolutely, yes.
Great. Let's not lose this great energy. There's a couple of questions I wanted to combine again. I like combine to look at here. There's a lot of people that are probably tuning in right now that may feel it's overwhelming. The thought of it, where do I start? Where do I begin? And so one of the questions was, how do you embrace AI as a leader if you're not technical, and what types of is there a type of math you need to know, or what are the things that somebody who feels overwhelmed right now, who's listening to this with enormous amount of interest, but what should they be thinking and feeling and knowing and doing?
It's a great point. You know, I from personal experience, right now I'm working through a fintech startup that I work with another big financial institution that's not very familiar with AI technologies, and they've been operating through the years by outsourcing much of their tech development. And one of the challenges for them right now, and more broadly to the question that I was asked, is to first understand what's even possible to do. Like if you're working in financial services and you provide a certain type of service to your clients, what can you do with AI? Is it necessary to have AI? Many times the answer is no, we don't need it. We can run this thing pretty well without any fancy AI, but sometimes this can really be a game changer. But how can you make the determination if you're not familiar enough with the concepts and terms? So the first step is just understanding what is out there and what can you unlock with the aid of these tools. Project it onto your own business and understand first, do I need this? And if I do, how big of a change is this going to create in the organization? That's one of the reasons we're actually launching this course. Is I think we want to have people to educate people about what the possibilities are, but also what the pitfalls are, what the challenges are, and to understand that not every business requires massive implementation of AI tools. You can do is sometimes with very basic solutions that are quite adequate for your purposes, and just differentiating and knowing if it's A or B is sometimes the critical decision to make early on.
Right, great. Ranjit asks, is AI, you know, the reality, and you're saying right now, AI is for real. I think that's something you said right now, like we're definitely at a moment here, an inflection point, as Rita McGrath would say. And so is this creating and boosting job opportunities with, you know, I mean, is it an enormous growth in job opportunities for AI, and how should they look at that?
Yeah, so the impact on the job market is going to be significant, in my opinion. And again, a lot of people who think of AI as automation, they worry about the fact that we're going to be automated out. Like there are a lot of jobs will be automated out, but it's really not AI. You know, some things like you know, giving your suitcases at the airport for check-in, and it's not really necessary to have somebody, an agent, do that. With that, we can automate. Amazon solved more complicated problems, so we can automate that away. AI is a different solution space than automation. I was alluding to that earlier. I think what it's doing is creating a lot of opportunities for people who are educated in the field. And there are various, you know, startup economies, like in Israel, for example, that I'm quite familiar with personally, where there's a huge shortage of AI engineers and data scientists. The university just can't chuck them out at the pace that the companies are hiring them.
Right.
And it's changing a bit the focus of companies in terms of where they're hiring. The other thing that you're going to see is that there's going to be an improved efficiency in many areas, and that efficiency will lead, I think, to greater productivity. Like that technology I was mentioning that's deployed in the hospital, it's not going to remove any need for physicians or nurses, but it's going to make their job much more effective. We're going to see much lower mortality rates, much reduced readmissions. The whole thing, just process-wise, will work better. And I think around these new processes, there's going to be another ecosystem of jobs that will be created. We're not there yet, but we're heading in that direction, I think.
Great. Well, I'm so glad you made the distinction between automation and AI, because I think the immediate fear is that, oh, this means loss of jobs, and there's, you know, humans will no longer be needed. And it's more about, you know, obviously, like you just said, in the hospital situation, making the job better, more robust for the person. Also, the other side of that, better customer, you know, experience. I mean, at the end of the day, that's a better customer experience if you have better processes. I'm going to end on the last question. It's similar to how I end a lot of the webinars. And you know, again, there's so many people here today, a lot of great comments, a lot of energy. We're so happy you could join us today. What can someone do today, next, you know, to learn more about AI? You know, we have the program coming up in the fall, obviously, but what else can they do to sort of keep this energy going today?
Yeah, I mean, it's a great point, and it's like very forward-looking also. I think, again, there are a lot of resources for if you want to, you know, further your understanding of AI, and it ranges from these type of MOOC courses that are given at Coursera and other similar platforms, which again, some of them I know personally the people who designed the courses, and they're quite good. And the other thing is, again, there are these various opportunities like the course that we're giving. And again, I apologize, it's not a marketing pitch here, but really a lot of effort is put into trying to make the material accessible. I think one of the difficulties people are seeing is just a lot of these things are relatively technical, and there's a lot of effort that needs to be put in just translating them to bring them within the grasp of people who are not technical. And ultimately, it's the people who are not technical that are actually driving most of the big decisions. So I think that bridging that gulf is really essential, and that's one of the things that we're trying to achieve here. So for those of you who are interested, and again, don't have technical background, are not engineers, or not, computer game geeks, etc., there are a lot of places where you can go and just further your understanding. And as I said, step one is to just understand what the tools are and what's out there and what's possible. Then you can make the next steps in determining what's relevant for your organization, etc. And I think just one last comment related to the earlier question, I would view the whole area with a lot of optimism. Don't worry, don't treat it with trepidation. It's not about regressing jobs out of the job market, etc. It's not going to happen. In fact, you're going to see a lot of new innovative job opportunities come about. I mean, companies that have been, just going back to my medical example, companies that have been producing devices like Philips and GE will be hiring a lot of people to provide all this support for the AI technologies they're going to be launching over the next 10 years. And the circles around that will translate over also to institutions like hospitals and healthcare organizations. That's going to be huge circles of employment that just don't exist right now. But the need will basically lead to those circles being created and propagated forward. So in general, think about this as really a huge opportunity. I'm not trying to make it into a euphemism, but it's a huge opportunity also in terms of the labor market.
Wonderful. I like this optimism. It truly is optimism. In our discussions about your upcoming program, again, artificial intelligence for business transformation, I'm so excited about your optimism about it. And as someone who may not feel that they're technically savvy in this, I think they're going to have an enormous benefit and feel very optimistic afterwards. So thank you so much for today. We look forward to the program in the future. It's exciting to see you on campus with our beautiful low library behind you. We have a very nice view from your office. Thank you everyone for joining us today. On behalf of Columbia Business School Executive Education, Professor Zeevi and myself, we wish you a good, safe day. Thank you.
Thank you all very much.